All
right, my name is Trey Echoles.
And I'm Kania.
And today we present our research on the sex differences in the role of estradiol on recovery after cerebellum lesion in the zebra finch.
So a bit of background onto our project is the cerebellum is traditionally known to be associated with motor coordination, such as multi-joint movements and posture. Recent research has shown that the cerebellum plays a role in spatial memory, and recent discoveries have shown us that sex hormones like estrogen play a role in protection and repair of the cerebellum. And what we know about the cerebellum is that, again, it is involved in spatial ability. We have found out that lesions of the cerebellum impair procedural learning, such as sequencing and planning, for example, a puzzle. There has been a correlation observed between Parkinson's and damage to the cerebellum, and we know that it is highly steroidogenic, meaning it is hormone sensitive. And the steroid hormones in the brain are estradiol, a neuroprocessing, protecting, and repairing hormone. And estradiol upregulates after damage. We have found that aromatase synthesizes estradiol from testosterone. And like I have said, the brain is steroidogenic. And we use the zebrafinch model of steroid plasticity. And the reason we do this is that the brain is more plastic than mammals, and their brain is even more highly steroid sensitive. We have found out that males and females have similar levels of estradiol. Males have higher testosterone, but females upregulate aromatase more than males after cerebellar damage. And the goal is to test sex differences in the role of estradiol and aromatase contributions to behavioral deficits after cerebellar damage in the zebrafinch. And our subjects are adult zebrafinches, 1 to 2 years old, weighing between 12 to 19 grams. And previous studies involving the zebrafinch have shown that lesions of the cerebellum impair balance and spatial ability in the finch. And we had 2 testing apparatuses. We had the spatial maze and the log roll. And the spatial maze is a circular arena with an exit hole carved out into the side, placed on a hot plate about 50 to 55 degrees Celsius. And 3 visual cues are placed outside of the spatial maze. And the log roll is a cubed cage apparatus placed on a hot plate with a spinning log roll perch in the center of it. And the spatial maze procedure is that the birds are allowed about 2 minutes maximum to try and escape. They are given 1 minute rest in an aviary, and the birds are recorded with an animal tracking program during the trial. Each subject has 4 trials per day over a span of 7 days, and at the end of the 7 days is a probe trial. 2 days later, we do a spatial recall. In the probe trial is a trial to testing to see if the birds actually use the visual cues to escape. So the visual cues are rotated 180 degrees and the escape hole is removed entirely. And the log roll procedure is the birds were placed in a clear box with a rolling perch. These birds participated for a maximum of 2 minutes. The birds were recorded using a camera, and we counted the amount of tail dips that were recorded on the birds, indicating the change in posture and balance. And each bird was given 1 trial per day over the course of 10 days. And we had 4 treatment groups. We had the cerebellar lesion group, we had the cerebellar lesion plus letrozole group, we had the cerebellar lesion plus letrozole plus estradiol group, and we had the sham lesion, which was our control group. And each group had 6 males and 6 females, so they were split evenly by sex. And we would create these groups by doing a stereotaxic surgery, meaning we would cause a puncture lesion in the brain. We would then apply the drugs directly to the lesion, and we would give the birds 36-hour recovery time.
All right, so a couple predictions that we had prior to testing the birds in the testing apparatus. For the spatial maze, we predicted that the sham lesion group would escape faster over days than our lesion-only groups. We predicted that our lesion-only group would escape faster over days than the lesion plus the aromatase inhibitor of letrozole groups. We predicted that our lesion plus letrozole plus estradiol group would escape similarly to the lesion-only because they now have that backup of estradiol to make up for their aromatase inhibition. We predict that there would not be any sexual differences in the lesion-only group as well as the sham lesion groups. We also predict that the lesion plus letrozole groups, the females would have the advantage. And when it came to the probe trial, we predicted that the birds would actually use the visual cues to escape instead of just remembering where the hole was at. Very similar prediction when it came to the log roll as well. Sham lesion will perform better over days, and lesions will perform better compared to the lesion plus letrozole. No sex differences between the sham lesion or the lesion only groups. And the lesion plus letrozole will have advantage when it came to the females. And so we looked at three things when it came to testing the four groups out. That was distance, velocity, and latency. For each one of these, we all saw a linear effect, which means that they improve over the course of time. We see that in distance, seeing that the birds traveled to the goal, as well as when it comes to velocity, we wanted to make sure that they was improving in their speed of traveling to the goal. And the main one that we especially looked at was latency, which is how fast they were able to escape over time. So one great thing of variability that we saw between these that kind of did not match our predictions was when it came to the females. So at the very bottom, we have the lesion plus letrozole plus Estradiol group. This group only had one bird in it, so we're gonna have to look more into that when we have more, but it is still good to look at in comparison that they did improve over time. But the biggest thing is to look at is for these three groups right here. So for the female, you see that the lesion plus letrozole group performed the best, and on the other hand, their sham lesion group performed the worst, which did not match our predictions, and we don't really understand where this advantage comes from. While when you look at the males, you see that the sham lesion performed the best, while the lesion plus letrozole performed the worst. And that matched our predictions, and we're not really sure what happened when it came to this or what led to this advantage. And when you look at this for the log roll, you actually see that it matched our prediction. You see that the sham lesions for both groups performed the best, as they say, consistent with their tail dips and didn't have a great variability. While you look at the lesion groups and the lesion plus letrozole, you see that they performed a bit worse. It took them a bit longer to get adjusted to the log roll. And again, you have that fourth group, and that's why we have this one right here, which helps us look at without that fourth group getting in the way. And you see, again, as I said, sham lesion perform better compared to the other two lesion groups. And so in summary, what we just need to do is we need more subjects to account for this variability that we had in the testing, as well as to make up for that fourth group that only had one bird. We also see that males and females do not respond similarly to the treatment. As I said, the females, their lesion groups had an advantage when it came to compared to the sham lesion group. While with the males, the sham lesion groups had the advantage, and the lesion or the aromatase inhibited groups performed worse compared to the other groups. As I said, we saw a significant linear effect when it came to distance, velocity, and latency. And we also saw that all the birds did use the visual cues when it came to the probe trial. So in conclusion, what we see is that males and females don't have the same spatial learning deficits after they receive lesions. You see that females, for some reason, have an advantageous benefit from it, while the males, they do seem to have those deficits and need their aromatase synthesization from testosterone to account over the course of days. We also do see that there is still enough estrogen aromatase to allow for recovery, because all the birds were able to complete the trial. It's just this aromatase inhibition matter and their speed of learning the trials. And finally, what we saw, as I already said, males do seem to have a deficit when they have their aromatase inhibition, while the females seem to have a biased upregulation or advantageous benefit after receiving that lesion. And we're not really clear of why they have this benefit. So future developments that we might need to do to account for this is we might need to just do more research on estradiol and the differences between sex, as well as we might need to perform adult disassociation where aromatase is blocked for each sex. So final acknowledgements and thank yous. Just want to thank everybody who was here to listen to our presentation. We also want to thank our professor and mentor, Dr. Day, as well as the University of Mississippi Biology Department, former graduate assistant China Ray Dearman, as well as former student assistant from Alcorn, Jervy Maya Powell. Again, we want to thank you all for your time and listening, and that will conclude our presentation.